Hello everyone, welcome back to Skill Talk. So in the previous video we understood that what is phase and how phase helps to confirm us the faults like unbalance, misalignment, soft foot and looseness, right? So now in this video we will be going a little bit more deeper. So because you know that many of us they think that they are using the phase correctly, but in reality we often make mistakes, especially we mixed up the concepts of absolute phase and the relative phase. And also there is a like normal, like horizontal, vertical and axial. These phases are known as the directional phases. So today we will be clearly understand this. So we'll be discussing in detail that what is the absolute phase and what is the relative phase, and also that all the directional phase like horizontal, vertical and axial, right? So let me be very clear. If we do not know that which type of phase we are looking at, so it's very easily that we can draw the wrong conclusions, right? So that's why it's important that we should be knowing that which phase we are using. So because many misdiagnosis happens not because the phase is wrong, but because the phase is misinterpreted, right? So before using the phase to make decisions, we must first understand that what kind of phase that we are measuring. Okay, so let's start with the first one, that is the absolute phase. So now what is this absolute phase? So absolute phase, it means that the vibration phase measured relative to the shaft position, right? So this phase help us to diagnose what is the location of the exact shaft. So to measure the absolute phase, what we need normally, we will be needing a one vibration sensor, or you can say the accelerometer, okay, or you can say the displacement probe, and also we'll be needing a phase reference, okay, usually known as this you can use as a tachometer or the key phaser, or the laser trigger. So the tachometer normally tells the analyzer that what is the exact angular position of the shaft, right? So now what will happen, that the analyzer, what analyzer will do, analyzer will compare the shaft position and the vibration timing. Okay, so the shaft position the analyzer will be getting from the tacho, and the vibration timing it will be getting from the our sensor, right? So normally what happened, that these both will calculate the absolute phase angles, right? So normally in overall one statement that we can say is this, that without the shaft reference there is no existence of this absolute phase. Okay, so normally let's take now example, that normally when we are using this absolute phase. So this absolute phase normally we are using in the rotor balancing, right? Whenever you people are doing the balancing, definitely you are using one trigger and one or two sensor, depend on the type of the balancing that you are doing, single or dual plane. And mostly you will be seeing using this tacho, combination of this tacho and sensors in cost up and cost down analysis in the turbines, and different process equipments. And also you will be seeing where there will be the the any kind of a resonance studies, or any kind of advanced aerodynamics is taking place. So normally you will be seeing it during that time. So in normal route base that we are doing daily, the data collection of vibration data collection, you will not see that anyone is carrying the tacho along with the sensor, right? So absolute phase is not always required for day-to-day routine based condition monitoring program, right? So now the next one is the relative phase. Okay, so this type of phase mostly the we field analysts normally use it. Why? Because it's kind of a comparison between two signals. So what is the relative phase? Relative phase means it's a comparison between the two signals. Here you will be needing, what you will be needing here you will be needing two sensors. Okay, let's say one is the sensor A or another one is the sensor B, right? So normally if you want to measure the relative phase, what happened, that you will be needing at least a dual channel vibration analyzer. With the single channel it's not possible to measure the relative phase. You can measure the first one that we have discussed, that is the absolute phase, with that single channel. But if you want to go with the relative phase, so definitely you will be needing two or more than that, right? Kind of a channel analyzers. So now let's take one example. Let's say that you want to compare with the movement between the outboard or the inboard bearing, or you can say the one is the drive-in side and one is the non-drive-in side bearing, or you want to have any kind of two surface, maybe the motor versus pump you want to compare, or you want to compare gearbox versus motor, or you want to compare any kind of a direction, horizontal, vertical, axial, or axial versus vertical, right? So this is called sensor to sensor phase comparison. Okay, so normally relative phase does not need a tachometer. So this is the main thing that you have to remember, that absolute phase need a tachometer, relative phase it doesn't need a tachometer, right? So now in the relative phase, normally where we are using this relative phase, we use especially in the troubleshooting. What's the troubleshooting? Let's say that you want to confirm the what kind of a problem it is. Let's say you are getting same symptoms, but you are confused that whether this machine is unbalanced or misalignment. So what do you do in this case? You will be using the relative phase and compare and reach up to the conclusion. Same thing if any looseness issues is there, or any software confirmation you need, or or any kind of structure to structure or machine to machine comparison you want to do. So this will help you to compare the exact movement of at two different places. Okay, so now normally overall what we, if we want to simplify this, that what is the absolute phase? Phase normally tell us where is the shaft, right? And the relative phase, what the relative phase will tell? Relative phase will tell that how machine components are moving relative to each other. So both are correct, but they are kind of a answer of different questions, right? So if there is a no shaft reference, that means you are not looking at the absolute phase, you are looking at the relative phase. Please remember this thing, right? This is a key thing that normally people don't understand, right? So now let's talk about the directional phases. So what are the directional phases? Normally that axial, horizontal, vertical, three different directions. So these the phase that we measure in these directions are known as the directional phases. So let's say in the axial phases, what happened that if I will tell you, okay, give me the actual phase of this machine of this particular location, so it will be measured along the shaft, and it's normally in, if it's the actual phase, so normally it's very important in any kind of bend shaft issues or misalignment issues. So high axial phase difference often normally confirms the misalignment. So normally you will see that people are taking the axial phases, especially in the case of misalignment. Now if the same thing you will be go with the horizontal phase, so they are more sensitive to the the looseness, unbalance, or any kind of a foundation issues, or especially the structural flexibility issues, because normally the machines are vertically grouted with the help of bolts. So if there is any flexibility in the structure, since the it's there is no any kind of additional strength has been added in the horizontal side, so normally you will see that there will be a rocking kind of movement to and fro, especially in the horizontal side in the machines, right? So normally if there is any kind of a phase instability is there in this case, that means there is a kind of a red flag for this particular machine. Okay, sorry that in the horizontal I forgot to mention the unbalance, but just unbalance is also a key thing in the horizontal phase. Same thing if you go with the vertical. So in the vertical also, if you will be having, if you having any unbalance issues, if you having any the issues related to the stiffness or any kind of a foundation looseness or bolt loose or something like this, that everything you will be getting in the vertical phase. So vertical phase tends to be stable in the pure unbalanced cases, right? So phase must always be interpreted together with the measurement of the direction. So this is a very important thing. Now we will be discussing the the most common mistake that normally we analyst normally makes. This normally mistake that we are making in, especially in the directional phase, and that is especially in the axial side. Okay, so what mistake can we do? We will be discussing that. Okay, the actual phase. So first let's count the common mistakes that we make. Sometimes that looking at the phase numbers, right, maybe we wrongly misinterpreted, right? And let's say without we are not checking what is the references, what is the direction of the sensor, what is the orientation of the sensor, right? So especially in the axial side. Why in the axial side? Normally let's say that you are taking the want to check that whether this machine is having the misalignment issues or not, and you have placed the sensors. Normally what happen, if you want to diagnose the misalignment, what you will do, one sensor you will be putting in the axial side of the motor drive end, and another one at the, let's say, in the pump drive end, right? So in that case what will happen, that normally sensor one phase is towards the towards the left, and another face of the sensor, that is the sensor B, is towards the right side, right? So in this case, what happened, the sensor orientation is different. One is facing towards the north, another one is towards the south. So remember this thing, that in this case what you have to do, whatever the phase readings that you are getting, so you have to plus 180 degree, right? So then you will be getting the exact phase reading. So in this case, right? So this is a very important thing. So always remember that whenever you are taking the actual phase reading, so this is the important thing that you have to take care, because phase is a very powerful tool, and sometimes such kind of things you will make you to reach at the wrong conclusion. Okay, so let's summarize this. So absolute phase normally is referred to the shaft position. Always remember this. And relative phase means comparison. Just go with the name, relate, right? Relative. So relate means comparison between the two signals. That means you are relating two signals, right? So absolute with the shaft position, and relative means two vibration signals comparison. And the directional phase is very simple. You know that the phase in the particular direction, horizontal, vertical, axial, right? So guys, this is what for this video. In the next video we are going to go even more deeper in the phase, especially the phase measurement without tachometer, and also we'll be discussing some orientation errors, and and when the phase data should not be trusted, right? So now in the last, the interesting thing, that is the challenge. Okay, so two questions I will give you today. Please mention your comment, answer in your comment section, right? So if you, let's say, first question, if you do not use a tachometer, so which type of phase you are measuring? Okay, please listen to again. If you don't use a tachometer, which type of phase you are measuring? And the second question is, which direction is most important for the coupling misalignment? Okay, so these are the two questions. Please drop your answer in the comment section, and definitely if any query or anything is there related to this video or any of the topic of the vibration analysis, because slowly I will be covering all the topics of the vibration one by one. And if any kind of issue or any kind of special video that you want from my end, especially in this any kind of condition monitoring field, it can be through vibration, thermography, or anything, right? So just let me know in the comment section. I will definitely try to make that video as soon as possible. So thank you guys, and we'll meet you in the next video. Till then, take care, goodbye, and keep watching Skill Talk. Thank you, bye.